Trigonometry notes. All right, let's get these going. So when we say trigonometry, we're talking about those good old-fashioned triangles. First one we want to talk about is sine. And I hope all of you remember that sine is opposite over hypotenuse. Let's take a look at our first example over here, where we have this triangle that has a 30-degree angle, a hypotenuse of 8 feet, and an unknown side over here. So if we list this information into our equation that we just talked about, we get sine of 30 degrees, because 30 degrees is our angle, is equal to opposite. Well, the opposite is unknown. It's this x divided by 8, which is the hypotenuse. We figure out that this is just equal to 4. Next one we want to talk about is cosine. And cosine of x is equal to adjacent over hypotenuse. We're going to take a look again at another example, this one down here. We're going to see that we have cosine of 45 degrees. Again, that 45 degrees is just referring to this angle is equal to the adjacent. Well, this time the adjacent is 10 feet because that is the side that is next to that angle over the hypotenuse. The hypotenuse is unknown because, as we can see down here, we don't have a value for it. That's why it's just x. We're going to manipulate this and solve. So we multiply the x over. We get cosine of 45 times x is equal to 10. Next, we're going to divide the cosine over and get 10 divided by cosine of 45 is equal to 14.14. So 14.14 is the answer for how long the hypotenuse is. Next, let's take a look at tangent. Tangent of x is equal to opposite over adjacent. Again, in case you forget, here is our triangle that has all that information on it. I highly recommend writing this down somewhere so that you guys can go back and look at it in case you need it. But let's take a look at an example problem over here to the right. So here we have a triangle with an angle of 55 degrees. We also have an opposite side that is 200 feet and an adjacent side that is unknown. So we're going to end up using tangent. So we're going to end up using the tangent function. We find out that tangent of our angle, which is 55 degrees, is equal to the opposite, in this case 200, over the adjacent, in this case just x. Again, we multiply that x over, we get tangent of 55 times x is equal to 200. Divide tangent 55 from both sides. We find out that 200 divided by tangent 55 is equal to 140.04. So 140.04 is referring to this adjacent side. Easy ways to remember all this. SOHCAHTOA. All right, we've all heard it before, and we'll all hear it again. SOHCAHTOA just means sine of opposite over hypotenuse, and cosine of adjacent over hypotenuse, and lastly, tangent of opposite over adjacent. SOHCAHTOA. Okay, important things to remember. All angles in a right triangle will add up to 180 degrees. So that's true for all angles in any triangle, but specifically the right triangle is what we're worried about today. The next thing we want to know is that a straight line is equal to 180 degrees. So this line right here has 180 degrees in it, which means that from here all the way to here, it's going to equal 180 degrees. So if this is 48 degrees, in order to figure out how many degrees are here, we would just do 180 minus 48. That would just give us 132 degrees. Lastly, we need to remember the Pythagorean theorem. And the Pythagorean theorem is just hypotenuse squared is equal to adjacent side squared plus opposite side squared. Another way you guys have seen this is a squared plus b squared equals c squared. In this case, this could be the opposite, this could be the adjacent, and this can be the hypotenuse. The hypotenuse is the one that is on the opposite side from the 90-degree angle. So this is our hypotenuse in this case. Let's talk about inverse trig functions now. What if we don't know the angles? Well, we can still continue using SOHCAHTOA, but this time we need to use the inverse functions. We know the opposite and the hypotenuse, but we don't know the angle. No problem, we'll just use sine inverse. And sine inverse tells us that opposite over hypotenuse is equal to the angle now. What if we know the adjacent and hypotenuse, but not the angle? Well, we'll just use cosine inverse. So cosine inverse of adjacent over hypotenuse will give us the angle. And lastly, we know the opposite and the adjacent, but not the angle. We just use inverse tangent. Inverse tangent of opposite over adjacent will give us the angle. Let's take a look at an example problem. First things first, when you approach angled problems, make sure your calculator is in degree mode. Make sure your calculator is in degrees. Go ahead and click the mode button right here. Scroll down to where you see degrees. Move over so it's blinking over it, and then hit enter. Now your calculator should be in degrees. To exit this screen, click second, quit, and now you're back to the main menu. If we want to double check that our calculator is in degrees, just hit sine and type 30. Close parentheses and then hit enter. Your answer should be 0.5. If I was still in radians though, and I did this, my answer would now be negative 0.988, and that is wrong. Sine of 30 degrees should be 0.5. So again, click mode, scroll down, move over to degrees, hit enter, and then cancel. Second, quit. To get our trig functions, we can just click on them right here, sine, cosine, and tangent, and they just pop up like so. If we want to get our inverse trig signs, we have to click second, and then the trig sign that we want, sine. Now I'll notice that I have sine to the negative first. That's inverse sine. You can go ahead and clear that. Same thing for inverse tangent. Second, tan to the negative first. My recommendation to you guys is that whenever you're doing any sort of trig or anything on your calculator, always, always, always use parentheses. So if I have an opposite side and a hypotenuse, 8 over 10, just always close your parentheses. So when we approach this problem, we actually notice that Superman is forming a triangle. And not just any triangle, a right triangle. So what does that mean? Well, if this is the angle that we're looking for, this would be the adjacent side because it is next to that angle. And this would be the opposite side. And the 100 meters is referring to the hypotenuse because that's across from the 90-degree angle. Therefore, if I wanted to figure out what angle Superman was taking off from, I would need to find a trig function that incorporates adjacent and hypotenuse. The only trig function that does that is inverse cosine. So I have inverse cosine of adjacent over hypotenuse. My adjacent is 75, my hypotenuse is 100. I find out that my answer is negative 41.41 degrees. If I plug this in my calculator though, I would just get positive. But I'm telling you that it's negative. And why is it negative? It's negative because it's under the x-axis. So imagine this line as the x-axis. This angle is under it, so therefore it's going to be a negative angle. So let's summarize what we just talked about on the previous slides. Everything that we mentioned was in regards to a right triangle. So again, a right triangle is a triangle that has 90-degree angle in one of its corners. If we have a right triangle, that means that we're going to have a hypotenuse, an adjacent, and an opposite side. All of these are in relation to some angle. The angle would have to be right here if this is our adjacent side. Now that we have a right triangle and an angle, we can use our trig functions. So we said before that sine of theta is referring to our angle, is equal to opposite over hypotenuse. We also know that cosine of theta is equal to adjacent over hypotenuse. And lastly, tangent of theta is equal to opposite over adjacent. The inverse trig functions are exactly the same, just opposite. Sine inverse is opposite over hypotenuse is equal to theta. Cosine inverse is adjacent over hypotenuse, and that's equal to theta as well. And lastly, tangent inverse is opposite over adjacent, and that is also equal to theta. Last but not least, we can't forget Pythagorean theorem, and that just says our hypotenuse squared is equal to the adjacent side squared plus the opposite side squared. Our last super important piece of information is that any angle that is under the x-axis, so what I'm drawing right now, will give us a negative value. If you're ever stuck, make sure that you're just identifying your angle first and then start labeling your sides.